Hi, welcome back to this channel. We are going to start with chapter 5, hydrocarbon. In this video, we focus at the part of the alkanes first. So now, let's try to define and classify the hydrocarbon into aliphatic and aromatic, then saturated and unsaturated hydrocarbons. Next, we need to learn how to draw the structure and also name the alkanes. So basically, we need to name the alkane with straight chains, branch, with the cyclic compound or and also with the alkyl group as the substituents. Looking at the name hydrocarbon, we know that this organic compound only contains carbon and also hydrogen. So for this hydrocarbon, we can divide them to two main groups, which is aliphatic hydrocarbon and aromatic hydrocarbon. So in the aliphatic hydrocarbon means the hydrocarbon is with open chain or can be with the cyclic structure. However, for the aromatic compound, they have to have contain at least one benzene ring. Next, the aliphatic hydrocarbon can be divided to another two main groups, saturated, at where only consists of single bond, while unsaturated hydrocarbon will contain of multiple bond, which is either carbon-carbon double bond or carbon-carbon triple bond. Now let's start with the alkanes. So the general formula for alkane is CnH2n plus 2 if it is an open chain alkane, while the number of the smallest n value is 1. However, for the cycloalkanes or the alkane with a cyclic structure, the general formula is CnH2n, at where the minimum n is referred to 3, because when we have 3 carbon, it will form a structure with the shape of triangle. Saturated hydrocarbon contain only carbon-carbon or carbon-hydrogen single bond, and then each carbon in the alkane is sp3 hybridized, means that basically their shape is tetrahedral, and then they need to bond to 4 sigma bond, which also maybe we more prefer using the term there are 4 single bond, and the bond angle will be 109.5 degree. Let's answer tutorial question number 1. Classify the hydrocarbon into aliphatic and aromatic compound. So as we understand, an aromatic compound always consists of a benzene ring. So the chemical formula for benzene is C6H6, at where you will notice the ratio, the number of atoms for the carbon and hydrogen, the ratio is almost always equal to 1 to 1. So based on these characters, we can deduce that C6H6 and C6H5CH3 are the aromatic compound. Okay, aromatic hydrocarbon. Wow, next we look at the C6H12. The general formula is CnH2n. So from here, CnH2n, there are two class of the hydrocarbon consists of this general formula. One is cycloalkane, and then another one is alkene. So no matter this is cycloalkane or alkene, generally they are considered as aliphatic hydrocarbon. So if this is cycloalkane, so this hydrocarbon is saturated. If it is an alkene, so it is unsaturated hydrocarbon. And then for the alkene is with the open chain structure, while the cycloalkane may has the cyclic structure. Then next we will continue with C6H14, at where the general formula is CnH2n plus 2. So this is the general formula for alkane. So this C6H14, this hydrocarbon is saturated aliphatic hydrocarbon with open chain. Okay. Last compound that we're going to discuss is CH3 double bond, CH2 3CH3. So from the structure here, it's very obvious that consists of carbon-carbon double bond. So this is an unsaturated hydrocarbon with open chain structure. Okay, before we discuss the tutorial question, let us check how, if we are given a name, how we going to draw the structure. So first, basically, we have to identify the parent name. The parent name normally is at the end of the right side. Okay. Then next, we are going to label the carbon 1 from the left. And then next, we will draw the suitable substitute based on the name given. Okay, let's look at the tutorial question number 3. So draw the structural formula for the following compound. Let's look at the 1-bromo-3,3-dichlorohexane. So that means this is the parent name. And then for 2-ethyl, 1-isopropyl, 3-methyl-cyclopentane. So cyclopentane is the parent name. 4-set-butyl 2,3,7-trimethyl-octane. Octane is the parent name. 2-bromo-4-cyclobutyl 2-iodoheptane. Heptane is the parent name. Okay, then now we start to draw the structure as we already identified the parent name. So from the parent name hexane, so we have the idea that there are 6 carbon. 1, 2, 3, 4, 5, 6. 6 carbon. Like as we mentioned just now, we normally will, if we are the one who draw the structure, so we will number the carbon from the left. 1, 2, 3, 4, 5, 6. Then now we look at the substitute. We have bromo, and then bromo has a number of 1. Means that bromo will attach to the first carbon. And then we have 3,3-dichloro, so means that the substituent is the chloro, and then di means there are 2 chloro. So these 2 chlorine atoms attached to carbon number 3. So that's why the number 3 appear twice. Means that both chlorine are attached to the same carbon. After we draw this, then we are able to continue to complete the others bond using the hydrogen. As we know, carbon always have 4 bonds. So first carbon already have 2 bonds. So that means they have another 2 hydrogen. Second carbon also similar case, already show 2 single bonds. So means they have another 2 bonds will bonded to hydrogen. Carbon 3 already show 4 bonds. So no hydrogen will attach to the third carbon. While fourth fourth carbon also need another 2 hydrogen, same as fifth carbon. But the sixth carbon only have 1 bond, so means that this carbon still need to bond to another 3 hydrogen. So this is the structure for 1-bromo 3,3-dichlorohexane. Question B. As just now we already identified the parent is cyclopentane. So if there is cyclopentane means that there is a shape. So you can like draw a cycle with 5 carbon. So it's cyclopentane. So looks like a a pentagon. Then the first carbon, 1 isopropyl. So you can number any carbon from here as the first carbon because this is not the straight chain. So let's say as usual we take this one as the first carbon. Okay, so and then isopropyl. So there are a few common substituent here. So from the name propyl, we know that there are 3 carbons. So we refer to here. So if the 3 carbon is in the straight, so it is known as propyl. If there are branches, so this one we will known as isopropyl. So now you will try to draw. Okay, so you imagine for this part is attached to the cyclopentane. So if this is the carbon that attached to the isopropyl, so here we have 1 carbon and then attached to hydrogen. Okay, so settle for this one. Then we also have CH3 at the top and then CH3 at the right. So the position for these 2 CH3 and 1 hydrogen can be at any place as long as it's attached to this carbon. Okay, so then now like just now we mentioned, this one we will consider as this is carbon 1. So then we have 2 ethyl. So if you have 2 ethyl, you can clockwise or you also can anti-clockwise. There is no problem. But normally we prefer follow our habit, which we always clockwise. So down here will be the carbon number 2. So carbon number 2 have the substitute known as ethyl. At where when we look at here, ethyl is the one with 2 carbon and then is in the straight chain. So you just sambung here CH2, CH3. So at the same time you will notice this carbon have 4 bonds, this carbon also have 4 bonds. Okay, so the next one will be 3-methyl. Okay, so that means if you already choose that clockwise, then you have to follow. So this one will be considered as third carbon and then will attach to methyl. Methyl means consists of 1 carbon only. Okay, so we are going to here. Okay, so I repeat again, methyl. Also, here we can see the methyl. Methyl means consists of 1 carbon. So draw 1 line out from the third carbon and then you can label CH3. So this is the structure for 2-methyl, 1 isopropyl, 3 cyclopentane. So before you submit this, you can erase the carbon 1, 2, 3. Now proceed to question 3C. 4-sec-butyl 2,3,7-trimethyl octane. Octane is the parent which consists octagon, consists of 8 carbon. So from the left to the right we have 8 carbon, 1, 2, 3, 4, 5, 6, 7, 8 carbon. So we just follow the name here. 4-sec-butyl. So that means the sec-butyl will add the 4th carbon. So 1, 2, 3, 4 is around here. So then now we refer to here sec-butyl. So because you are still new, please always refer to this table to get the idea how to draw the structure of 4-sec-butyl. butyl. So before we go draw the structure, just roughly mention what is the meaning of butyl. So if you can see the term butyl like what you learned in SPM, it is referred to 4 carbon. Then how about this sec? So basically this sec is stand for secondary. Means that the carbon that attached to the parent chain is a secondary carbon. So when we circle this one here, we can see one carbon is bonded to hydrogen. This carbon still have 3 bonds. One bond is bonded to hydrogen, another one bond is bonded to CH3, and then another bond is bonded to CH3CH2. So then now we already settled for the 4th set butyl. Then we go to methyl 2, 3, 7. Means that there are 3 methyl group at these 3 position. Carbon number 2. So since here is very crowded, if we put the CH3, then maybe you can put the CH3 at the top. 2nd carbon, 3rd carbon, and the 7th carbon. So we know that the longest carbon chain have 8 carbon, so that means 7 is at the 2nd last carbon. Okay, so now as usual, we cannot left the structure like this because this is not belongs to slender structure, also not belongs to expanded and condensed structure. So we have to complete the number of hydrogen. So first carbon here only show 1 bond, means that still have another 3 bonds. 2nd carbon already have 3 bonds, still need another 1. Same case as well to the 3rd carbon. So we can put H here. The 4th carbon also same case. So if you want to show the bond, no problem. So the 5th carbon CH2, the 6th carbon CH2, the 7th carbon CH, and then the last carbon will be CH3. So when you want to draw structure like this, as long as the question does not specify that they need expanded, condensed, or slender structure, you can combine them. Okay, like this part of here, you maybe will notice over here looks like it's expanded, but then over here it looks like condensed structure. There is no problem if this happens. Question number D. 2 bromo, 4 cyclobutyl, 2 iodoheptane. So heptane is the parent. So consists of 7 carbon. 1, 2, 3, 4, 5, 6, 7. Bromo at the 2nd carbon. So at the bottom also okay. At the top also no problem. And then we have a cyclobutyl. So from the name cyclo, we know that there is a shape. And then this shape have to have butyl 4 carbon. So basically it's a square. Will attach to the 4th carbon. Okay. Then next one is 2 iodo. So iodine will add the 2nd carbon as well. Then now we are going to complete the hydrogen. First carbon need another 3 hydrogen. 3rd need another 2, and then this one need 1, another 2, another 2 hydrogen, and this is another 3 hydrogen. So this is the structure for 2 bromo 4 cyclobutyl iodoheptane.